Right, good afternoon. So today we're looking at question 3 and hopefully 4. If time permits, we'll carry on to question 5. This was the June, May 2021 Department of Education rewrites paper, or the ABET paper. Okay. Right. So for question 3.1, we are told that if R is 1 over 5, so already what do we know? What type of pattern is this? It's a geometry. Is 1 over 5. A common ratio is 1 over 5. A is 2000. Determine the nth term, the general term of the series. Of course, it's geometric, so Tn is equal to AR in minus 1. So Tn is equal to 2000 into R, which is the fifth raised to the power n minus 1. Okay. So that's a general term. In 3.1.2, they ask you to work out T7. So for T7, it's going to be 2000 into 1 over 5 to 7 minus 1. Okay. So that would simply give us 2000, open brackets, 1 over 5, or 0.25, 0.2, raised to the exponent 7 minus 1, which is 6. Gives you an answer of 16 over 125. Okay. Then in question 3.1.3, we are asked which term of the series will have a value of 16 over 15,625. So in other words, this here is your general term. That's your nth term of the sequence. Or in this case, the series. Okay? So, Tn is defined as 2000 into 1 over 5 raised to the exponent n minus 1. And it's equal to, so I can drop that, 16 over 15,625. Okay? So at this point, we just need to solve for x. Or in this case, n. So I divide by 2000 both sides. That cancels. So that's going to be 1 over 5 raised to the exponent n minus 1 equals. So we put on the calculator, 16 over 15,625, which must be divided by 2000. Okay? That gives us 1 over 1,953,125. So this now becomes an exponential equation to us, not so? So I need to know what this denominator can be written as. So I'm going to take the reciprocal, because I can't factorize this in products with prime factors as it stands here. So I take its reciprocal. The denominator, please shift, factorize. So it's actually 5 to the exponent 9. Can you see? So that is going to be 1 over 5. Of course, then n minus 1 is equal to 1 over 5 to the exponent 9. Because 1 to the exponent 9 is 1. Okay? So when bases are the same, exponents of course are equal. So therefore, n minus 1 is equal to 9. N has to be equal to 10. So that means to say the 10th term of the sequence holds a value of 16 over 15,625.
Is it possible to use log in this question?
Sorry?
Is it possible to use log in this question?
Yes, you could use logs at this point here. Okay, we've taken that out there. The question is, can I use logs? Yes. The exponent, which is n minus 1, is equal to log 1 over 1,953,125 base 1 over 5. Okay, so this is n minus 1 should be equal to then. Let's punch that in our calculator. It's 1 over 5 as the base. And that is 1 over 1,953,125. This gives you 9. Alright? So n has to be 10 anyway. So either as we equated the denominators with the basis, sorry, with the exponents to be equal, we could have used logs as well. Yes. Any other confusion thus far? Nothing. Okay. And this is the end of question 3. No. 3.2. Okay, I didn't cut 3.2. I'm going to pause this quickly. Okay, that was not the last question in question 3. So you've got 3.2. I hope you guys forgot about this one. So I don't have to explain this one. No, I'm joking. I love maths, no? People, we are told in 3.2, consider the geometric series where sigma, which is Tn, n is equal to 1, to infinity equals 27.
Grade 12C, English learners, can you please report to room 36 now? Grade 12C, English learners, to report to room 36 now. Thank you.
Okay, so here we're given this here. So what do we note from here? What can we determine? What is told to us at that point? Sum to infinity can be picked up. So the sum to infinity here is 27. Not so. Right? And then we are told that sum of 3 terms is 26. Okay? There has to also be geometric, of course. Calculate the constant ratio R of the series. So we know that S infinity follows a formula. What's the formula? A over equals 27. Not so. But A is also equal to what? 27 into 1 minus R. Why did I do that? Ionism. Why would I want ionism? No. There's 2 unknowns. And we'll go into what? Simultaneous equations. So already I'm preparing the equation for simultaneous. And A is the subject of the formula, and this is equation 1. I can multiply 27 out, but I don't know how the other side is going to look yet. Okay? So that's equation 1. Let's look at equation 2. S3, let me use the other color. S3 is equal to 26. So what is the sum of n terms for geometric? A into R to the n. And what is your n value here? 3 minus 1 over R minus 1. Not so? So it's A into R to the n, which is R to the 3 minus 1 over R minus 1 is equal to 26. Can you see that? You think I want to cross multiply here? No. So here I'm seeing already a link between. We cancel. You all agree with that? So I'm not going to multiply out here. I can factorize this here to be R minus 1 into R squared plus R plus 1. I can take the difference of cubes there. But I don't need to yet. We must first substitute. By substituting it, you're going to get rid of that. If you had factorized, you must then multiply it. Okay. And this is now equation 2. So what do I do now? Substitute. I'm going to substitute equation 1 into equation 2. Substitute equation 1 into equation 2. So wherever we see an A, we replace it with 27 into 1 minus R. Make sense? And let's go with that. So it's going to be 27 into 1 minus R. Remember, that's your A value. Okay? Which must be multiplied by r cubed minus 1 over r minus 1. Not so? But is r minus 1 the same as 1 minus r? No. So what do? Swap it around. And a negative comes out. Not so? Again, why does swap it around? So that this here can cancel. Is equal to 26. So from here it's a matter of simplifying. 1 minus r cancels 1 minus r. So in other words, I've got negative 27 times r cubed minus 1 equals 26. So what do I do now? Divide by negative 27. Oh, what else could I have done? Otherwise, what else could have been done? They say I can divide by negative 27, or I could multiply negative 27 in. Not so. So I divide by negative 27. That cancels. So r cubed minus 1 is equal to 26 over negative 27. Take it over becomes positive. So r cubed is equal to 1 over 27. And what do I do now? Square root, cube root. Both sides. Do I add plus or minus here? No. When do I add plus or minus? Square root of? Fourth root of? Any even root. If you introduce an even root to the sum, then it goes plus minus. But this is not that case where you're introducing an even root. It's an odd. So that's going to be a third. 1 over 3. So R gives you an answer of a third. Any confusion, people? Before we move on? No confusion, okay? Let's sort out. Okay, so now we're looking at question 4. In question 4, we are told the lines y equals x plus 1 and y is equal to negative x minus 7 are axes of symmetry of the function f of x equals negative 2 over x plus p plus q. We must show that p is 4 and q is negative 3. How do we link this with the information given in order for us to calculate p and negative 3 and q? Yes?
So the lines of symmetry will give us the components of P and Q. So I'm thinking we can substitute that into
that equations, okay? So you want to substitute into that equations, but then you got 4 unknowns you're working with. You're working with unknown P, Q, X and Y.
No, what I'm saying is we're only looking for X and I would say that P is equal to that equation essentially. Q is equal to that equation and then substitute each kind of that.
So you managed to get P to be 4 and Q to be minus 3, doing what you are saying.
It's just an idea.
Oh, it's an idea. You didn't do that. Okay?
I think that as it is equal x, it would be you divide two set y equal to 0 and y equal to x equal to 0 and find x and y value and then substitute it into.
So you want to set y equal to 0 here for this year.
Then which one?
You set y is equal to 0 here, you will be working out the x intercept of this line. If you had worked out the y is equal to 0 here, I've worked out the x intercept of that line. So it's not going to take us where we need to be. Anybody else? At the back?
So I said that both equations are equal to each other.
So you worked out points of intersection.
Yes.
Why?
Because but then when I got 4, that's why I'm like, okay.
No. What you're doing is correct. But I want to know what was your thinking. You wouldn't think. You just...
I just
You would have gotten 4 full marks. You see what happens is we got say that is the equation, that is the graph. No? we have an axis of symmetry, 1 going through there with a negative gradient. Y is equal to minus x minus 7. Okay? And we got 1 going through like this. Can you see that? Actually, it's drawn in the wrong quadrant now, looking at your x and y intercepts. But that's not what I'm talking about. What I'm trying to show you here is that if you're working out this point here, which he did was he did points of intersection of the two graphs, it actually gives you the coordinate where the two axes of symmetry actually meets. Or the asymptotes also meet. The axis of symmetry meets at the same point as the asymptotes meets. Can you see that, people? That is why it is correct what she did. Make sense? So again, to work out P and Q, we're going to work out the point of intersection of these two lines. Okay? So we have x plus 1 equals negative x minus 7. So we've got 2x is equal to minus 7 minus 1 is minus 8. X is then negative 4. Okay? That is your point of intersection of your x. Then, for your q, but we'll come back now to that. No? For the corresponding y values, y is equal to negative 4 plus 1, which is negative 3. So if I draw this graph, okay, x is negative 3, y is negative 4. So, this coordinate here is negative 3 and negative 4. So if I had to draw a line going through like this, it is 1 plus, so it will be 1 there, the other one is coming through like that. Does it make sense, people? So this is your P and your Q value will come from these values here. Can you see that? Remember, your X will always have an additive inverse effect. So like this. It's the other way around. Eh? X was minus 4. Okay. I'm marked the other way around. X is minus 4 and y is negative 3. So that is the point of intersection, or the point where the asymptotes meets. Remember, the one line is going through like that, and the other one is coming this way through. So negative 3 is that value there, your Q value. Can you see that, people? So we can say therefore Q is negative 3 and P. If you look at P, P is always the additive inverse. This is minus 4, so this has to be positive 4. Because if your denominator is x plus 4, then x can never be equal to negative 4. Can you see that, people? So, and P is equal to positive. Okay, any confusion there? No? The next question is question 4.2. It says calculate the X intercept of F. How do you calculate X intercept? We let y equal to 0. Okay? So this is your equation of f of x now reads, you put here on the side, f of x is equal to negative 2 over this here, x plus 4 minus 3. Remember, this is now your equation. Now say for argument's sake you didn't get this in the previous sum. You didn't manage to solve this. You must use these values in the given equation in your next step. Does it make sense? This is also the reason why this is given. So if you can't get this out, you can use that information in your next calculation. Okay? Remember now, that's the equation. X intercept, let y equal to 0. People, this is your y. Not so? Does This is written in functional notation, so you say 0 is equal to negative 2 over x plus 4 minus 3. So take that over. So it becomes 2 over x plus 4 equals negative 3. So what do I do now? Cross multiply. Okay. So if we cross multiply here, I then get 2 equals negative 3x minus 12. Now what? Negative 12 over. So negative 3x is equal to 14. So x is equal to negative 14 over 3. They ask you for the x intercept of f. What difference would I have done on your answer if the question was calculate the coordinates of the x intercept? Let's put it in the coordinate form, which is negative 14 over 3 and 0. But it wasn't asked for that order, so you won't be penalized if you don't give it in that order. You understand the difference? Okay. Then in question 4.3 they say, sketch the graph of f. Clearly label all intercept with the axis and the asymptotes. Okay, so I'm going to just draw it here. So we can keep the rest of the information in focus. This is 4.3. Okay, so we start off by drawing the axis first. Not the axis, sorry. Your asymptotes first. What is the equation of your asymptotes? Y is equal to? Negative 3. And x is equal to? Negative 4. Remember when we draw these graphs, there are 2 points of intersection we normally draw when we write in. What are the 2 points of intersection? Your x and your y. Did I work out the y intercept? No. So let's work out the y intercept. How do you calculate y intercept? Get x equal to 0. So in other words, what I'm working here is f of 0. Not so. So the equation is negative 2 over 0 plus 4 minus 3. So that gives us negative 7 over 2. You all agree with that? Which is also negative 3.5 or negative 3.5. I always tend to write it in decimal or in mixed fraction form so that you can see clearly the whole number there. Okay? So negative 3.5, if this is negative 4, negative 3.5 on your x will be there. Not so? Nope, I made a mistake. Oh, is this your y-intercept? I'm thinking now I made a mistake. So the reason why I'm thinking it's wrong is because this is negative. So it has to lie in this quadrant and this quadrant here. And I've got a dot there, so now I'm making a mistake somewhere. So of course, your y-intercept is there. Not so? So the graph that is negative 3.5, the graph comes close there, it doesn't touch. Remember that your asymptote is going through there. The graph comes close to the asymptote and never touches. So that's the first part of the graph. And on the other hand, it's going to cut your x-intercept at negative 14 over 3. Negative 14 over 3 is also negative 4 and 2/3. Is that correct? It's 12 is 2, so it's 2/3. Or negative 4,67. No. So if this is negative 4 here, this is your asymptote here, negative 4. This is negative 3. So negative 4,32 is approximately there. So again, the graph comes close, but doesn't touch. And there's your hyperbola graph. Okay? Any confusion? All right. Let's look at question 5. I'm going to pause the video again. Okay, so now we're looking at question 5. In question 5 we are told, sketch below are the graphs of f of x equals negative 2x squared plus 4x minus 16 and g of x equals 2x plus 4. A and B are x intercepts of f. C is the turning point of f as well. Okay? Over it? You okay?
Yes, sir.
The other girlfriend don't sound okay. Am I making so much noise? Okay, so in question 5.1, the question says calculate the coordinates of A and B. Calculate the coordinates of A and B. What is A and B? X intercepts. How do you calculate the X intercept? Right. Sounds like you guys are going to do well in maths. So X intercept, we let y equal to 0. So we have 0 equals negative 2x squared plus 4x minus 16. Plus 16. Okay. So we can do one of two things. You can either factorize or the quadratic formula, or if you have the silver calculator, of course, you just punch that into the calculator. So you got negative 2, 4 and 16. Going to be x is equal to 4 or negative 2. But have you answered the question? No. They want the coordinates of A and B. So therefore, A will be negative 2 and 0, and B 4 and 0. You all okay with that? You'll see we start to populate the diagram, because I'm going to take that off as space, as we need the space. Okay, so I would like to keep the diagram in focus. Okay, so we'll just delete or erase as we go along. In question 5.2, we are asked, let's just get 5.2 quickly. 3. In question 5.2, we are asked determine the coordinates of C, the turning point of F. So how do we calculate C? First derivative, not so. So F prime x equals negative 4x plus 4. We say that equal to 0, we drop that. So x works out to be 1. If we substitute 1 into the function, f of 1 is equal to negative 2 times 1 squared plus 4 times 1 plus 16. So they give me 18. So therefore C is going to be 1 and 18. That is one way of doing it. How else could we have done it? Minus b over 2a. Okay? So your axis of symmetry is minus b over 2a. It's going to be negative 4 over 2 times negative 2, which is 1. F of 1, as I showed you already, works out to be 18. So it's 1 and 18. How else could we have done it? Completing the square. So you can choose whichever one you want to do. Whichever one is your favorite. I know none of it's your favorite, but let's just say for the sake of it, this is your favorite. because they always get it wrong. That was all the reason why it's your favorite. I need some more space. So f of x is 5.2. F of x equals negative 2 as a common factor. It's x squared minus 2x minus 8. So if you're always getting it wrong, you do one of the other two methods. Okay? It should make enough sense. Plus a number to complete the square with, minus the same number. And what's the number here? It's going to be negative 2 times half, which is negative 1 squared, will be 1. Perfect square trinomial. Which is simply negative 2 into x minus 1 squared. Negative 1 plus negative 8 is negative 9. Multiply the negative 2 in is x minus 1 squared plus 18. Now, of course, your turning point is negative, is positive 1, is the additive inverse there, and direct there, which is 18.
So why is the 2 square?
That's what your coefficient basically. Alright? Any of those will get you the full marks in question. Let's look at 4.3, at 5.3, sorry. Question 5.3, take this out. In question 5.3, it says write down the range of f. 5.3 is a range of f. So the range is all possible y values. Not so. So, does this graph exist at negative infinity? Yes. How do we know it is existing at negative infinity? The arrows is going down. Negative infinity. So this graph exists negative infinity. And where does it stop existing at? 18. So in other words, y must be less than 18. Does the graph exist at 18? Yes. So it must be equal as well. Y is less than or equal to 18. Okay, any confusion? Right? Let's go to question 5.4. It's 5.5. Here 5.6. Yes. And the same. Oh, I love those questions. They have a lot of questions in it. No? Not because the marking is easier, no. So they can really test us like this. Delete it. 5.1. Which question we are now? 5.4. So what I'm going to do is I'm going to take this off here. So as I said, I'm going to try and keep the diagram in focus rather. It will be more beneficial to us. Okay. In question 5.4, we are told the graph of h of x equals f of x plus p plus q has a maximum of 15 at x equal to 2. Determine p and q. Wat van hier? Sorry?
The graph of x has
Transformed. Yes. Some transformation has taken place. Okay? So what is the current maximum of this graph?
15.
Currently? 18. So the graph of h of x is equal to that as a maximum value of this. So which graph has transformed? If. Transformation has been taken place on if. Can you see that? So currently it has a maximum of 18. Okay? And it occurs at which value of x? 1. So we want this maximum value now to be at 2. This is 1. So there's 2 and 15 is approximately. Let's say 2 and 15 is here. It might be outside the value. Can you see that, people? So in other words, this graph shifted down by how many units? 3 units. You all see that? So what I'm going to do is I'm just going to write it out like this quickly. That's 5.4. So X and Y became, it moved down. So it's Y minus 3. Not so?
Yes.
Right. And then it moves horizontally how many units? 1. It goes there. So that's a graph they're talking about. So it moves over 1 unit. So it becomes X plus 1. Now this is the transformation. If it's on your equation, then it's the additive inverse. Okay, can you see it? Right. But let's see what the question says. Determine the values of P and Q. The Q is no problem. What happens to this graph? Shifting down by how many units? 3 units. So Q is equal to minus 3. P. This graph is moving 1 unit to the right. So what must I say? Minus 1. Right? Well done. So Q is minus 3 and P is negative 1.
Are we looking for the actual values or
What's the question?
given the values of the P?
P and Q, and there we got P and Q. If they wanted the equation, then I would have then substituted that into the original form, and then I would have got the equation. Alright, you guys understand? Right. This is a good question. I like that one. Let's take this out. Delete. And 5.5. Question 5.5. Yes?
Wouldn't Q have been 15?
Q. No. You see what happens is, no? Say I completed the square. Okay? This is just for your explanation. I'm not going to change it. Purple. Okay. So what was the equation that when we completed the square earlier on? F of x equals negative 2 into x minus 1 squared minus, it wasn't minus 9. That to be a positive 18. Not so? Are you okay? Are you sleeping? Right. No, this was when I completed the square. Yeah, that's to do with the term. So if I take this into account here, you see h of x equals f of x plus p plus q. Okay? So what did we say? The graph is shifting 1 unit to the right. So I must minus 1 on the x. Not so. So wherever I see a x, I put a negative 1. So it's going to be x minus 1 minus 1. Can you see that? Squared plus 18. And then we said the graph is moving 3 units down. So it's minus 3. Can you see that? Which means now to say you got negative 2 into x minus 2 squared plus 15. Now without looking here, will this graph have a maximum or minimum value? Maximum. Will it have a maximum value of 15. And it occurs at an x value of 2. And this is where this fits in. Make sense? Okay, so here, the graph of h equals f of x plus p plus q has a maximum value of 15 at x equal to 2. Alright. But the question was to calculate P and Q, and that's how we calculate P and Q. Okay. Any other confusion before we move on? Right, so let's take this off here. We're looking at question 5.5. In question 5.5, question 5.5, this question, the question says, determine the equation of the inverse of G in that form. How do we calculate the inverse function? Remember, that is G. You interchange X and Y. Not so? So for the inverse, it's going to be X is equal to 2Y plus 4. Make Y the subject of the formula, so 2Y is equal to, we took the 4 actually over. So 2Y is equal to X minus 4. So I divide by Y, so X equal to, Y is equal to half X minus 2. So that's the equation of the inverse function. Okay. Any confusion there? Okay.
Sir,
Yes?
could you have to something in that form, or could you say X minus 4 over 2?
X minus 4 over 2 is also acceptable. Let's look at 5. Any other problems here, people? I don't know what's happening now again. 5.6. In 5.6 we are asked for which value or values of X will the inverse function multiplied by the function of G equals 0. Okay? Many ways I can do it. One that pops into my mind at this point. We know what the equation of the inverse function is in terms of X. Anyway, it's that thing. Not so. So we can then simply say
In this case, does the inverse function refer to gradient?
sorry?
Does the inverse function refer to the gradient?
No. The gradient is the first derivative. You're confusing yourself here with first derivative and with inverse function. Inverse function is the study of the graph in the reflected in the line y is equal to x. The gradient is the first derivative. Okay, so don't get confused. Okay, I don't know what's happening now. The graph is not playing along. So let's see now. As we said, we know what that is. That is simply a half x minus 2, that's the inverse function, must be multiplied by g. And what's the equation of g of x? It's going to be 2x plus 4. Where is that equal to 0? Is where each one of those are equal to 0. Not so? That's what the product, the rule tell us. The zero factor rule tell us. So it's going to be half x minus 2 is equal to 0. So it's going to be half x minus 2 is equal to 0. Half x is equal to 2, so x equal to 4. Or on the other hand, it is where 2x plus 4 equals 0. So 2x is equal to minus 4 and x equal to negative. Okay, any confusion there? Let's look at the last question before you leave. In question 5.7, it says if P of x is equal to f of x plus k, determine the value of the values of x for which P and G will not intersect. Okay? So what we notice here is that there's a transformation that happened on f of x. So what does that mean? If I look at the f of x function, let's go here, Miss Nine. If you look at f of x here, okay? Currently do this, if this was a graph of P, remember, it says plus K. So this graph of P is either moving up or down. Correct? Currently do they intersect? Yes. And now? Yes. And now? Yes. And now? Yes. Why? Because the arrows mean to say the sum is carrying on. Not so. But will it have cut here? Yes, it will cut there at one point only. Which means to say, I need to know what the equation of the tangent to this graph will be at that point. Okay? So, to work out the tangent of the curve, g of x becomes a tangent now to this graph. Okay? So what we do is, we say, we work out the first derivative, so f prime x equals negative 4x plus 4. Now this is a general gradient anywhere along the curve. Okay? So what we do is we say, okay, the gradient of g of x, is 2. Not so. So if you have 2, then f prime x is equal to 2. So it's going to be negative 4x plus 4 is equal to 2. So negative 4x is equal to minus 2. So x is then equal to a half. Which means to say the x value at which that point of contact occurs at is x is equal to a half. Okay. Now, what do I do then? Then, what I want to work out is the point of intersection. Okay? So what I do is I substitute a half into g of x. So g of a half is equal to 2 times half plus 4, which is 5. Not so? So this is going to be half and 5. That's the point. Alright. But if you look at the point, if this graph, remember, if I take this graph into account here, and I say that's a tangent at this point. Just take one graph up. That's a tangent there. What would that value have been? Okay? That's my question. What would that value have been? That value would have been f of a half. Okay? Which is negative 2 times a half squared plus 4 times a half plus 16. Let's work that out. Okay, can somebody work that out quickly? 17. Can't be 17. Sorry? 17.5. Right. So that is 17.5. So this point here would have been a half and 17.5. But remember, this graph has to move down. So how many units do I move down from 17.5 to 5? So this graph is actually moving down by 12.5. So it's moving in the what's the name direction? The graph moving down. So at k is equal to negative 12.5, the graph of P is a tangent to the graph of G. That means to say the graph of P is going to cut at one point only. Anything less than that, any value less than 12.5, it would not intersect any longer. So therefore, the K value has to be less than negative 12.5. Yeah, it has to be negative. Why? Because the graph is moving down. That's why it's negative. Alright. If you have any questions with regards to this, refer it to tomorrow's lesson. Okay? People, enjoy the rest of your day. Good afternoon, class.